Hello everyone, June the 9th. Alright, I said I'm gonna do AVL tree, but I don't feel like it today. Let's just finish this and then keep the ball rolling. We'll deal with this some other time. Find the smallest letter greater than target. Given an array of characters that is sorted in non-decreasing order. So it's increasing, right? Increase on the same. And a character A. There are at least two different characters in letters. Return the smallest character in letters that is lexically greater than target. If such character does not exist, return the first character in letters. The smallest character that is lexically greater than A is C. What does this mean? There are at least two different characters. So at least there are two. Okay. The smallest character that is greater than C is F. There are no character that is greater than, so we return this. Oh. It's just binary search? Yeah, I just binary search. Okay, this is actually a question. I don't know. Can we binary search non-integer values? I think we can. I mean, in the worst case, we just have to write a key because we have a key now. Okay, let's do this. Import from bisect. Import what? We want to find greater. The smallest character that is lexicographically greater than. Greater, right? We want to find greater. So if it's the same, we want bisect right. Yes. We want bisect right. Not sure. Bisect right. Letters target. And if I can return letters index mod len letters. I think this shall work, right? Let's see. Yep, I think it shall work. There you go. Binary search. $7.44. Binary search. Brute force. Binary search. No, it won't be. I don't know. I mean, oh, look at this. Bunch of easy questions here as well. But yeah, this is a really hard one. But that's not what we just keep moving on. Prime in diagonal. You're given a zero index two-dimensional array. Return the largest prime number that lies on at least one of the diagonals. In case no prime is present at any of the diagonals, return 0. An integer is a prime. We know prime. An integer val is one of the diagonals if there exists an integer I for which this equals val, and for an I for which this equals val. So it's just this diagonal and this diagonal. I remember on the other diagonal is the sum is the same, right? I mean, we can just get everything and find the largest. In this case, it's a 1, 6, 11. The only numbers present on at least one of the diagonal. 1, 6, 11, 3, 6, and 9. You have any better solution than this? Go through the whole thing? We go through the whole thing. How about the prime? Well, we find the prime. Hold on. Holy crap. 4 times 10 to the 10th. 4 times 10 to the 6th. Huh. Should I get everything out and go from large to small? Ah, we have to check for prime. Damn it. Here we have to write it ourselves. Just remember how to check for prime. Yes, we check every single one until square root. We check every single one until square root. If nothing can be divided, then that's a prime. Or we can speed it up. Once we check 2, we can just check all the is prime. There are faster ways to do this, but yeah, that's fine. We can just do this boolean. If n mod 2 return false. For I in range 3 to math.sqrtn for int this thing plus 1 and go 2 at a time. If n mod I is equal to 0, return false. Otherwise, return true. And of course, if n equal to 1 equal to 2, if n equal to 1, I shall return false. If n is equal to 2, return true. And then hold a second. What if you are 3? 3 is fine because I don't even go through this. So I just got, what if it's like 5? I should check for everything, right? 5, square root of 5 is still 2 something, so it'll be 3. 3 to 3, so we don't do this, so 5 is good. But what about 6? Oh, 6 handled, 4 handled. 3 is handled, 4 is handled, 5 handled, 6, 7. 7, still 2. 2 plus 1, still 3, still cannot go. 8, 9. 9 will do this, okay. 10, 11. 11, square root 11 is still 3 something, so we do 3. Doesn't divide. So I guess this is right. Okay. Then we'll just say diags equals, and for I in range n equals line nums. Okay. Diags.append nums I and diags.append nums I. It tells you n minus I minus 1. It already tells you. And then diags.sort. Let's reverse it. for d in x, if self dot is prime d, return d, what if nothing? Return 0. Let's see. So I can go to the 17. Should be good. I could save all the primes, but I guess that's not necessary. Just check the more tricky part is to write a simple function, right? To check for primes. Oh, sieve. Oh yeah, you can do sieve. Every value comes in. I mean, even is gone, so it's just to be the odd. And you can sieve the odd. Yeah, every value comes in, you just or you can sieve everything. Because it's 10 to the 6th. Ah, you want to sieve everything to 10 to the 6th? Yeah, sieve everything. Yeah, don't want to sieve this. Sum of distance. You're given a 0 indexed integer array. There exists an array of length where array I is the sum of I minus j over all j such that nums j equals nums I and j not equal to I. If there is no such j, set array I to be 0. Return the array. Okay, so what we want to do is say array I is the sum of I minus j over all j such that nums j is equal to nums I. So the nums, this is a 0, right? Array 0 is equal to 1. So we're going to find all the nums that equal to this. So 1 and 2. No, 0, 1, 2, and 3. So we add the difference. I see. What do you think? Well, what we need to do is at each position, we need to find what are the other position that's equal to this, right? So if we are the first position, now I think we just, go through the whole thing, record the indices. So like this value. So we know 0, 2, 3 has the same value. That's a group, right? And then 1 is by itself. And then 4 is by itself. Okay. Now we go through them. We go to the 0. How do we know 0 has connected to the other 2? How do we know they're connected to the other 2? We have a group, right? So we just go through the group, right? We find a group. Yeah, we create these groups, right? So in this first example, we have 0, 2, 3 is a group. So we just go through each group. We go to 0. We just want to know what is the value of this minus this and this minus this. So equals 5. Then we go to 2, right? Then we need to know the value of this minus this plus this minus this. Now the issue is we need to find it fast, right? So if you think about it, 0 minus 2 plus 3 minus 2, okay? What does it feel like? Well, I mean, every time you're on here, you need to minus this. So it's going to be this minus this plus this minus this, which is this value times 2 minus. So we need to do a prefix sum, okay? So we have a prefix sum, and for each one, like we have A1, A2, all the way to AN. And if we do an AK, so that's just going to be A1 plus all the way to AK minus 1. And then that is K minus 1, right? So it's AK times K minus 1 minus this plus everybody on the other side, AK plus 1 all the way to AN minus AK times K, no, N minus K. N minus K. Right? So we just need a prefix sum, so we know this, and we know this. Then we just need to find these two. Okay, let's get this done. All right, so we need a default dict first. Okay, then what we do, we say for indices equal to default dict a list for I and enumerate nums indices n dot append I. Okay, rest equal to 0 times len nums. Okay, then we just say for vowels in indices dot values. Okay. If len vowels equal to not is larger than 1, then we do something. If it's equal to 1, we remain 0. Then we say, oh, we need prefix sum. So from intertools, import accumulate. Okay. Then we just say presum equal to list accumulate vowels. Actually, does accumulate has accumulate from tools import accumulate. It does have initial. So if I have A1, 2, 3, right, and then we do list accumulate A initial equals 0. Yep, we can do initial. Initial equal to 0, right? So we have prefix sum. Now what we need to do is for I in vowels. Okay? For I in vowels. Remember, indices need to plus 1. Okay, for I in vowels. So for this position is going to be the total number on the left hand side, right? And then what's the total number on the left hand side? It's going to be I is the total number on the left hand side times I minus p sum minus p sum something Oh, maybe I don't even need to do this. Because p sum, I can just use this, right? P sum is what? It should be I minus 1. Ah, I do need this initial equal to 0. Because if I starts, hold on. I. Yeah. The p sum, we always need to go I plus 1 minus 1. This is on the left hand side, right? And then plus on the right hand side. On the right hand side, I first need to know the total number times I. No, I need to know p sum minus, right? So p sum something minus p sum something minus the count. So this is easy to do, the second one. So the second one is just going to be I plus 1. So you can remove all of that, right? And there will be these things. They are minus, they are minus, they are minus. And this is always going to be minus 1. That's easy. So what is the count? So the count is going to be Gordy. Let's get the count out. So count is always going to be n, right? Minus 1 minus I plus 1, still the count, plus 1. Okay, let's expand this. This will be a negative. So this plus minus, these two will cancel it out. So this will be this. These two will be cancelled out. So this is going to be res I is going to be equal to this. And then once we're done, we'll return res. Okay, let's give this a shot. 1 3 1 1 2 5 0 4 4 3 4 0. This is a terrible test case. Nums distance index out of range. Dude, which one? P sum? I? Oh. Yep. Damn it. For IV, enumerate, my bad. Enumerate vowels. So this is gonna be V. This is gonna be V. This is gonna be V. That is not how it's supposed to be. We got one of them right. The other two are not right. They are sorted. They are sorted. And how come it's still not right? Let's see. Let's print vowels, print p sum. Vowels, p sum, that is correct. And for I, so first will be 0. I got 5, right? And then I got this. This is a 1. V is 2. So that will be 2 on this side. Plus 5 minus I is 1. will be 2, 0, 1, 2. So this will be 3, right? This will be 3. Minus v is 2. Oh, that's now n. Dude, you bad. I don't even need len then. Yep, I got confused about the two. That shall work. Yeah, we can do, let's say, oh, what the hell are you doing, man? Give it a quick shout. Looks solid. Let's give it a shot. Looks solid. Find the groups of indices that belong together. Make sure they are sorted. Then use prefix sum to quickly compute the sum of differences. The sum of distances. So this is on. This is on. Yeah, this is on. Huh? I don't understand. Yeah, similar idea. Don't matter too much. Next one, minimize the maximum difference of pairs. You're given a zero indexed integer array, nums, and the integer p. Find p pairs of indices of num such that the maximum difference amongst all the pairs is minimized. Oh my god. Find p pairs of indices such that the maximum difference amongst all the pairs is minimized. Also, ensure no index appears more than once among the p pairs. Now therefore a pair of elements at the difference is okay, return the minimum the minimum maximum difference. So we can pick two pairs, right? We can pick p pairs. Once we pick p pairs, we're gonna have the difference, and among the difference we'll have a maximum difference. So we want to know from all p pairs, what is the minimum of maximum difference? And we define the maximum of an empty set to be 0, because p can be 0. P can be, wait, hold on. What is the minimum maximum difference? What if p is equal to 0? Exactly. So we don't take any pairs. That should be 0. Because p is p pairs. You have 1 pair and you have 0 pair, which means it's an empty. And that shall be 0. Hold on, let me just double check. I think it is 0. If p is equal to 0. Yep. Okay, so this one I can take 2 pairs. So among all different 2 pairs, so we're going to find a p pair. And what is the minimum maximum? So in here, one pair can be 1, 1, which means this value is 0. Another pair is 2, 3, minus 1. Yes, and the second pair is index 2 and 5. The maximum difference is 1. Okay, I see. All right, what do you think? Well, we need to find p pairs. And in order to minimize the difference, we want the values to be, the value in the pair to be as close to each other as possible, right? So what we might think is to find if we have any equal values. If we have equal values, we definitely take those, because taking those will allow us to have the difference to be 0. So for example, in this first one, if we do a thing, okay, 1 of 10, 2 of 1, 1 of 2, 1 of 3, and a 1 of, why do you use this? It's just, you don't need to be a list, but anyway. So when you go that, right, and we want p pairs. P pairs means the maximum number of pairs we can take from each one divided by 2, right? So we do that, we counter it, and then we go through everything. For all the things that are larger than 2, right, we'll divide by 2 to find how many pairs we can get, right? And this divided by 2, this is actually gone, we can get 1 pair, and none of the other is larger than 1. Okay, so that's how we get rid of some of the p. Now we have a remaining p that we have to deal with. Now what we need to do to find the closest, right? The closest. How do we find the closest? We'll sort this thing, 2, 3, 7, 10, and I'll go from front and then just check smallest distance, right? So we check this, we say, okay, we have a smaller distance of 1, and then we check smaller distance 4, smaller distance is 3, right? And then we just smaller distance, actually we can only use once. Well, if it's 1, we take it, right? If it's 1, we take it. What if the first is not 1? Okay, the first one can get some value, and next we can get some value, next we can get some value. And next we can get some value. But we can say, if it's a 1, we'll definitely take it. Like, why would you not take a 1? Right? Why would you not take a 1? But you have to know, because 1 is the smallest. But what if you have a 2 at the moment? What if right now it's a 2? So you have these values. Right, we can still do this, right? You have these values. Each one appear once. You do this, boom, it gives you a 3. Do you take it? You say, I don't know, I have to keep looking. So you keep looking. You keep looking, so you get another value. You keep looking, keep looking, keep looking. And once you find a small one, you say, okay, I'll take that. But you still cannot be sure, so you have to go through the entire thing, right? You go through the entire thing and then you know the smallest, the second smallest. How do you know? So we have to put them into an array, right? So let's say this is the distance is 3, and then we start from, let's say, 0 position. This is a distance, and then we have another position, da 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 da, and then we sort this thing. Then we go from the smallest, so we take it, okay? Then we say, boom, this one's taken. This and the values, right? Because these are all unique. So we can say this value and this value has been taken. And next one, we have a value, and then we say, can we take this value? If it's taken already, we just cannot take. If it's taken already, we cannot take. Well, we have a situation where we take a small one, and that forbid us from taking something else, and then we are forced to take a bigger one. Can you imagine that? Yes, I can imagine that, but would that matter? So the question is, because we are basically greedy this thing, so the question is, what if I don't take the smallest? Okay, if I don't take the distance that's the smallest, will we reach a better deal? If I don't take the smallest, that means we are able to take something slightly bigger, or maybe the same. What if it's the same? It doesn't really hurt. Then we take something slightly bigger. I mean, we take the smallest. That just means we taken those, right? Yeah, let's say we have something small. 10 and 11. Okay. And then on this side, let's say it's 5. On this side, let's say it's 6. And then let's say we have 3 and 8. Well, if you put it out, it's not going to be like this, right? If you put it out, it's going to be 3, 5, 6, 8, 10, and 11. All right. They always say we have a 2, start with 3. We have a 1, start with 5. We have a 2, start with 6. We have a 2, start with 8. And we have a 1, start with 10. That's how we're going to get. And then we'll sort this. So we sort this will become a 1, 5, 1, 10, and then 2, 3, 2, 6, and 2, 8. Smallest go first. I would take 5, 6. I would take 10, 11. That's not gonna affect. What will affect, I think, is what might affect is consecutives. 1, 2, 3, 4, 5, 6. If we take this and we cannot take this, we have to take this. All right, but what if taking this is a better deal? That's what I'm worried about. So I'm just trying to design, of course, let's say, if I take this, let's say this is the 5, right? If I take this, I cannot take this. If I take this, then, well, if I take this, I can take whatever this, right? I can take whatever this. And what we're saying is if I don't take this, and I take this, then if I take this, I cannot take this, and I cannot take whatever this. I have to take like something here, right? So if I take this, I can only take something here. If I take this, then I can take this, or I can take this. So no matter what, I shall take the smallest first. I think the greedy does work, so let's get to it. I think greedy does work because it does not make it worse. Right? Because it does not make it worse. So the greedy says, the greedy says we take the smallest, right? The smallest we see. And the worry is if you take the smallest, you might forbid yourself from taking the one right next. And you say, if we take the one right next, which will give us a better deal. And we say if the one right next is the same as this, then, no, if the one right next can give me some good result, then I take this one, can give me the same good result. Therefore, yes, the greedy works. Oh, the feeling, the moment that you realize greedy works is really a good feeling. But first of all, we have to counter this thing, okay? Collections or import counter, right? So we say counter equals counter nums, and for key in counter, okay? Rest is going to be equal to 0. Actually, I don't even need to worry about rest at the moment. Yeah, let's just do it here. What do we do here? We'll say key value in counter.items. Okay. If v is larger than 1, all right, then we can say p minus equal to v divided by 2. And oh, maybe we can do div mod. Let's say qr equals to div mod v and 2, right? And then we say p minus equal to q, right? Or minus equal to q. And if r is equal to 0, I want to remove it, but actually it's fine. Actually it's fine. We can just say counter k equal to r, right? And of course, if p is smaller or equal to 0, then we just return 0. Done. We can take all the pairs with the same, right? Otherwise, we go through all this, okay, and then we need to find the ones that's, you know, yeah. See, that is why, okay, that is why I like to do it the other way. List counters.keys. That's why I like to do it that way. And v is just going to be counter k, right? And then it's going to be counter k. It's okay. We just do this minus this. And we can actually do this first, make sure. If not, then we say counter k equal to, we don't even need to do this. We have to say if r is equal to 0, okay, because I removed everything, then we say del counter k. We remove this. Otherwise, I can actually get the uniques out. Okay, uniques out. Okay, else, I don't even need to put it back. I don't need this because I put the unique out. I can just go through everything and then Oh yeah. I see. Items. All right, come back. We do items again. This is v larger than the div mod this if r, right? Then we say uniques dot append k, right? Else uniques dot append k. Okay. Then we're gonna sort uniques dot sort. We can sort the uniques, and then we need to find the differences, pairs of differences, and we say pair diffs, okay, equal to, for I in range to len uniques -1. Okay, sorted this thing. Okay, sorted this thing. We have something. What is this something? This something is going to be uniques I plus 1 minus uniques I. And we need to start from uniques I, right? So we sort this whole thing, and then we go from the front to the end. And then we say used is equal to a set. Then we say for diff and low in this. Okay, in this. What do we say? Diff is the smallest, right? So we just say if low is not in used, rest equal to low. Right? Rest will equal to low. And used dot add low. And used dot add low plus diff, because both are used. They're unique. You can only use them once. And we say p minus equal 1, right? And then if p is equal to 0, which means we're done, then we shall break, and then we'll return res. Okay, does it make sense? Yeah, we find a pair. If it's in use, we just keep going. I think it makes sense. Let's try this. 1, 2, 7, 1, 3. I mean, this one will be right. We know it was designed on this. Nums and p. Minimize nums and p. Nope, first one's not right. That is very interesting. All right, let's just get uniques and let's find a p. Uniques is 2, 7. That's right. That is right. Okay, result is 2. Oh, you don't equal to low, you equal to diff. My bad. Yeah, you equal to diff, you don't equal to low. You just add low and add low plus diff. Okay, let's take a look. We can throw something at it. Oh, I didn't try the 0 one. What if p is equal to 0? Aha. Nah, it's just like if p is equal to 0, return 0. Okay, I missed a couple of numbers. Okay, let's say 5. We should try another one. It's not a value. Oh, what did I do? Oh, my bad. Yeah, I have another one. Let's say interesting, right? Interesting enough. Looks about right. Actually, let me increase this to, I don't know how many values I have. It's 8. Dear God, it's still 0. I have 8 pairs that can be found? Yeah, it's bonkers. Can we get 10? Oh, 10 get a 1. Give it a shot. Let's see. Oh, God. One of those problems. Okay, so probably means either have a typo or greedy doesn't work. Oh, greedy does not work. Greedy does not work. Oh, I was wrong. Okie dokie. Let's see. 0, 1, 1, 3. 1, 0, 2. So if we get out, that will be 0 with 1. And 1 with 0 and 2 with 1. So we can say, okay, if I take this, if I take 0 with 1, then this is gone. I cannot take this, nor can I take this. Oh my, it's a little bit more complicated. Good test case, huh? How much did we do? Yeah, a long way to go, man. So basically for this, you shall take this and this. Oof. Maybe we need to DP this thing. I don't know. Yeah, greedy doesn't work. At least the first part, greedy doesn't work. Either choose to take it or not take it. Right? Let's say if I take this, then it has to be from this towards the end and define 2. If I don't take this, then it's this towards the end. Maybe DP will work. I don't know. Hold on. No, DP will, because you have a P, and P is the length divided by 2. If you do that, it has to be this with the length P. Not sure. Not sure if DP is gonna work. Because it's 2, right? You're having 2 scenarios. You have the index and you have this P. And of course P is only half. I don't know, man. Each index will couple with P. I mean, there is a early termination. Let me think again. And what if length is 1? If length is 1, P will be 0, so I don't have to worry about it. So if length is 2, it's just going to be the difference between the 2, right? If length is 3, right? If we have 3 length, we have A1, A2, A3, right? So we can say from this towards the end, the minimum of one pair is going to be A2 minus A1, right? And then from this towards the end, because I have 3, so 3 divided by 2, that's the minimum, is going to be 1 pair. So I can choose, I can say I either take this or I don't take this, so from this to the end. So I have whatever 3 is. Now we have 4, okay? Now when we have 4, we can say, we can have 2, P can equal to 2, or P can equal to 1, right? At this position towards the end. So if P is 0 is 0, and P is 1, we can have a value. P is 2, we can have a value. P is 2, basically we take this, and then we go this for 1. Yeah, I know, at each position, P starts to grow. P starts to grow. This feels like timeout to me. Because you have to go through every single one. Imagine you're at the front, right? If you're at the front, you have to go P equals well, I mean, you have to go from P, right? So which means you take the current, and you have to go from this towards the end. P minus 1. What is that? And then you can say I don't take this. then you go from this to the end, find P. That's two scenarios. You find out P, then you have to find P minus 1. You have to find P minus 2, P minus 3, all the way down to 1. Right? All the way down to 1. I am not sure if this is something that you want to do, because it's going to cost O n times P. I doubt it. That's the solution. I mean, you can try it. Let's just write it first. If it times out, at least we know that the solution is right. What do we do? Sort. We sort it first. So dp for I in range minus 2. Okay, and for j one to minimum of p, right? We either take p or a total number of pairs we can form. What is the total number of pairs we can form? Total number of pairs we can form is n minus I, right? N minus I is total, and then we divide it by 2. That is total number of pairs we can form. N plus 1. Right? And what do we do here? We'll say, we'll take j, right? And to take j, it's either we do not, right? We take the current, which means I to I plus 1. And then we'll do this. Ooh. Hold on. You need 3. You need 3 DP arrays for this. Really? 3 DP arrays. Yeah, you need 3 DP arrays. Gordy. If I don't take the current one, then I use this. If I take the current, I use this. So I have a DP2, Jesus, DP1, DP2, and temp. That's 3. right? And this basically says temp j, right, shall equal to minimum. I either take the current, so it's going to be the minimum of something and the minimum of something. I either take the current, which is nums I plus 1 minus nums I take the current, and I'll do dp1 j minus 1. No, dp2 j minus 1. Or I don't take the current, then directly dp1 j minus 1. J, yeah, dp1 j, right? So that's temp j. I will do all of those. Once we're done, then dp1 dp2 shall equal to temp dp1. We finish everything all the way to I equal to 0. Okay, I equal to 0, and then we hit everything, right? We hit everything, then we have dp1 equals temp. So we shall return dp1 p. Does this make sense? Does not make sense, man. What the hell? Well, yeah, because this is not minimum, this is a maximum. It's still not right. What the hell? I think the starting position is not right. The starting position shall not all be 0. dp1 is the next level. dp2 is the minimum of everything, right? And what do we want? Yeah, it's the maximum. Is the minimum maximum. So this is correct, because I'll need to find a current one, a difference, and this will take the maximum. And this is giving me trouble at initial, right? At initial is dp1. dp1 is the maximum difference. I think the starting position, this shall be math.infinite, otherwise I won't be able to. Ha! Wow, that is very interesting. Okay. So we have a little bit trouble dealing with this at the moment. I think this is correct. What is wrong is the starting position is wrong. So I start from here, right? And then I say j is equal to 1, n minus n 2, 3, 4. 4 minus 2 is 2, was 1. So j equal to 1, yes. So temp 1, and maximum this position minus this. No, this position minus this, 3 minus 1 is actually 2. This is 2. dp2, this is 0, so we'll get 2. And temp j shall equal to 2. Okay? So next one coming up. Next one coming up will be this position, right? So if we do 1, we'll say I'll take this, and I'll take, if this is temp, this is dp1, this is dp2, so now we'll do dp2. So it's whatever this. If I take this, or I don't take this, and I take dp1, did you even hit 2? If I'm at 0, 4 divided by 2 is 2, 2 minus 1 is 3. I do take 2. Hold on. Okay, this is the last one. That's not correct. Because starting from here, if it's 1 pair, it should be 0. 2 pair, it should be, no, 1 pair should be 0. 2 pair should be 2. We take this, that's 1, and then we take this. The DP relationship is not right. Should be 0, right? So it's 1, and dp2 should be 0. Or dp1, 1 is 2. That's hold on, one at a time. Okay, first one come in. Inf, and then 0, 0, 0. Alright, that's fine. And then j is going to equal to 1 because I can do right, I start I is 2, 4 minus 2 is 2, 2 divided by 2 is 1, minimum is 1, 1 plus 1 is 2, so j equal to 1, okay? So temp 1 shall equal to maximum nums 2 plus 1, this is 3, minus this will be 2, and dp2, which is this one, right? Because I take the current, I need to find the next one, but it's going to be 0. So it'll be 2. And then dp1 is going to be infinity, so that will be 2. So temp 1 is 2. This position is 2. That is correct. That is correct. Maybe this is not 0. Maybe this shall be math.inf. See that? It's math.inf. Because whatever you haven't fit, right, this shall be math.inf. Otherwise, you might hit something you haven't hit before and it becomes 0. Okay, now the question is different. I think this shall be right, but you just say shall be right, huh? Ugh. That's not it. I don't know. I'm just trying random stuff. Maybe they all should be like this. What do you think? I think it's in a timeout, but I'm willing to just give it a shot. If it times out, then we'll think about it again. Yeah, it times out. It's okay. I'd expected it. Oh, very close. Alright, it's late. Man, I have 2 problems now. Got stuck. Oh, think about it again. Let's mark it. Alright, I'll see you guys tomorrow. Adios.